Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. And before I get started, I just want to thank those of you who have subscribed to the channel recently and those who have subscribed for a while. I really appreciate it. It helps the channel. So I hope you'll consider subscribing if you haven't already. Also, please consider giving a thumbs up if this is helpful to you, share with others, and click on the notifications bell so that you know when other videos come out. So that out of the way, in this video, we're going to look at addition and subtraction within 100. And the patterns and the approaches that I share in this video, I hope you see will actually extend as your child moves up through the grades. So what happens quite often is a district, the state, will have objectives, things that they want your child to accomplish. And the one thing to keep in mind as you read these, if you look at these for your child in whatever grade they're in, these are the things we want them to accomplish by the end of the year, not at the start of the year. Now, what some people do is they see this and they think, oh, we better get started if my child's going to be able to add within 100. But you see, for an entering first grader, that's going to be very overwhelming. And this is a first grade standard. Okay. So what we want to do and what we'll look at in this video is some of the things that you may see your child doing in grade 1 that you're thinking, hey, when are they going to get to that adding within 100 piece? And what I hope to show is how we are doing that and building all the foundation for that. So by the time they get to adding to the 100, they're ready for it. It will not be overwhelming because the ultimate goal is that your child understands that math will always make sense and that they learn to love it, not hate it. We want them to be mathematically powerful as time goes on. So I've written 2 different standards from a grade 1 list of objectives. You can see how loaded the first one is, right? We want them to add within 100, which means adding a 2-digit number and a 1-digit, a 2-digit and a multiple of 10. They should be able to do this. And this is the really important piece for us to remember. Using concrete models, stuff they will touch, drawings that make sense. And then we're going to use strategies on place value, properties, and a lot of times we think of properties for algebra as something that happens later in school. But notice we're starting to build those ideas this early, okay? So that's really important, relationships between addition and subtraction. Okay, we are relating it to a written method, but you may find that I usually suggest doing that near the end of the process, not at the beginning. And this could be in a single lesson. We're not talking about long term here. Okay. And then you have one where we want them to be able to mentally find 10 more or 10 fewer, 10 less. So 2 different objectives that we're going to look at in this video and think about what you may see your child doing and how that leads to here. So we're going to start with the 10 more, 10 less, that second objective first. One thing in grade 1 is we're going to try to strengthen the counting patterns that they learn in kindergarten. And so getting them to understand what happens within a decade, right? I don't have to memorize. If they need to count to 100, I don't have to memorize 100 number words. I need to know the patterns, that the pattern repeats within every decade. Right? It repeats kind of how I handle going across decades. And I need to be able to count by tens, starting with 10. And that's very common. You might hear your child going 10, 20, 30, 40, going really fast to show off. Make sure they can go backwards also. That will be important for the subtraction side. And then eventually, we're going to have them count by tens, but with an anywhere start. So you can see I've got 28 here. And notice how I'm using a manipulative material, a concrete model or a picture of a concrete model. These would be something that your children may use in school. I'm base 10 materials, or you might see them using rods of Unifix cubes, they're called, that they can stick together and pull apart. Now I've got 28 showing here, and then we go 38, 48, 58, starting to look at patterns and just get them used to counting by tens with anywhere starts. Now, you may see in your child's classroom something called a 100 chart, where it goes 1 to 10, 11 to 20, all the way up to 100. And you might see them looking at 28 and reading the numbers down a column. Now, we want to think about that experience is different from this one. That experience gets them seeing some patterns, but it's a numeral naming. It gets them naming the numbers that are pointed to, that they see down a column. This is looking at quantity, which I found helps strengthen those relationships we want as they get into computation. Now, let's say we've been counting by tens with an anywhere start for a while, and I've got 38 showing. I might say, what's 10 more? See, we start to predict 48, 58. What would be 10 fewer? So I can use this model to have them predict, and then we test. What would be 20 fewer? Get the idea? So we're going to purposely use some manipulative materials to help them with those skip counting patterns, but that's because we have that objective of counting 10 more or 10 fewer mentally, being able to just name that. And as we get into this, you'll see another piece of it that we just looked at. Now, instead of leaving this as this long paragraph, let's break it into pieces. We want them to add 2-digit and 1-digit. We want them to add 2-digit to a multiple of 10. We want them to understand that when you add 2-digit numbers, tens go with tens and ones go with ones. And that base 10 model is going to be really important for us to think about because that's one of those concrete models we'll use. Now, I would reorder this. I would start with adding 2-digit numbers and a multiple of 10 for what I just showed you, right? That we're looking at that counting up, counting by tens. What is 10 more, right? I ask you 20 fewer, but see 30 more. And this starts us thinking about when you have that model you saw, you put the tens together and the ones together, right? So this idea that if I want to do 30 more, how do I come up with what 30 more is? Tens have to go with tens, ones have to go with ones. That's a key understanding for your child to have. And we're going to use models like these base 10 blocks to help them build that understanding. Now, adding a 2-digit number and a 1-digit number, you may find that your students are using some strategies that are different from pure memorization. It's important that your child eventually knows all these facts. 8 and 5 is 13. But it's also important that if they know their facts, they also have some imagery for it, because the imagery is going to link us to the property. And for our talented kids in math, we want to make sure they have the imagery that links them into that algebraic thinking. Okay, so kids who are great at memorization, fantastic, but we don't want to forfeit this. Now, what happens here, you can see 8 in a 10 frame and 5 outside, and we can fill the hole by sliding those two red ones over. So now we've shown that 8 and 5 is the same as 10 and 3. 10 and 3 is much easier to find. Your child would do work with teen numbers and see the 10 and 3 for a 13. What's happening here is we've essentially thought of that 5 as 2 put together with 3. And instead of associating the 2 with the 3, we're going to associate the 2 with the 8. See, this is a visual representation of the associative property. And your children in grade 1 may not see the notation with those parentheses in there, but that's the concept we're building the foundation for. So we've got the associative property. We shift that over. Now let's say we take it up to that 28 plus 5 problem. See, I can still use my filled 10 frames. Do you see the 28 with the black dots and the 5 with the red? What I'm doing at the fact level to build the imagery for bridge to 10, associative property, I do the same thing here. I can think of that 5 as 2 and 3. Instead of associating the 2 with the 3, I associate it with the 28. Now, could your child just count up 5? Sure, they can. That's another strategy. But in the end, the counting on only will get us so far and isn't very efficient. This bridging to 10 using the associative property will help us when we get up to 3-digit, 4-digit, decimal addition. You see, even fraction addition. We want this strategy because the property always works. So once the strategy is built well in grade 1, I can use it to add a single digit to a double-digit number, like it shows in that strategy, right? Now, the other part of that was understanding you combine tens with tens and ones with ones. And I showed that a little bit in that counting example we did, right? But we're going to keep using these concrete models. And we just want to focus on the first part, not the sometimes it's necessary to compose a 10. We'll get to that. Now, let's say we have 64 and 23. You may find your children use a chart like this. It's a part total chart. It might have another name, but you can see the two parts at the top. You slide them together to get the total at the bottom. Let's say I have 64 on one side and 23 on the other. See, it's important that your child understands we don't count all the pieces that we've got there. We put tens with tens and ones with ones. And you may find that your children are doing a lot of work with that part of it before they get to adding, because we need that understanding really strong with them, that 10 is its own unit. And later they'll see 100 and 1,000. Okay? So if we build the understanding we need, we want them to understand it doesn't matter how I put the blocks in those sections either. It's still going to be 64 on the left and 23 on the right. So I don't have to put tens and then ones. It makes a difference the way we write numbers, position, but not when we use the models. I still have 64 and 23, and I still need to put tens with tens and ones with ones. Now let's look at the other part of this. See, it's a progression, and we build it through the experiences. And all along the way, we're hoping your child has those aha moments, those, oh, I get that. And then they become confident. That's what's really important, is building your child's confidence along the way so that they believe they can tackle anything in math. That's what we're shooting for here. Now, let's say I end up with a problem where I have 12 ones. One way I can make 12 is with the 12 ones, like I've shown here. But what's a way I could make it that would use fewer pieces, fewer numbers of pieces? Can you think of what that is based on what you've seen already, right? A rod of 10 and 2 ones. That's where it is composing a 10 if you have too many ones. That's the understanding. Now notice I'm using language like equivalency. What's another way, an equivalent way I could make it? Versus trading. Trading is an action we teach them just to get them to get to an answer. Equivalency is foundation for what they'll have to do with fractions later, equivalent ways to make the same fractional amount, decimal amount, and the same quantity. One uses the fewest number of pieces, so we can do it with our 10 and our 2s, but 12 ones also works, okay? Now, think of currency. Can you do equivalencies with currency later? Here in the US, our dime and our pennies, our nickels, we could make 12 cents many different ways. But the way to make it with the fewest number of coins, a dime and 2 pennies, it gives us that link. Now, here's the subtraction standard for the same grade 1 set of standards. And notice what this one says. It doesn't go into all of the 1 digit from 2 digit and that. It focuses on decades. It focuses in on tens. And one of the things that we hope your child understands is if they know something like 2 plus 3, then they can do 20 plus 30, two tens plus three tens, and they can do 200 plus 300, two hundreds plus 300s, and they could do 2,000 plus 3,000. Those are very easy for them to generalize and extend up. They can use a fact understanding they have to do more complex numbers. Here, we're kind of doing the same idea. If they could do 6 remove 2, then they could do 6 tens remove 2 tens. The imagery, though, we want in their mind are those base 10 materials again. This is the unit that we're playing with. We've got 6 tens, we're going to remove 2 tens. We've got 60, we're going to remove 20. I hope that helps. I hope it makes sense why you might be seeing the things you're seeing versus direct practice of a standard, how we're trying to build up understandings with your children so that we build that confidence with them. And we're going to be doing some of the computation things when we're doing counting practice, when we're doing other types of practice. And we might be looking at equivalency versus always trading, right? We're building flexibility because we know for your child to be procedurally fluent, they need to be flexible. They need to be able to come at many different ways, and they need a strong number sense. So if you found this video helpful, I hope you did. Please give it a thumbs up again. Please share with others who might find it helpful. Again, please consider subscribing to the channel and clicking on the notifications bell. I really appreciate your help with all of that, and thanks so much for watching.